Okay. Howdy, everybody. Tom Fernandez here. I'm back, and I'm going to talk about uh, the software that I'm working on. It's it's really a framework for making any kind of software, um, and it makes it easy to make multi-threaded, and it has a user interface that I like. You know, Mostly I just assign functionality to the function keys. Um, but we're going to take a look at it now. So what happens is you have the system here, and we'll look at the Solution Explorer. And I don't know how clear this is, but there's a special area, a folder in the Solution Explorer called App Specific. And this is where you put the code that runs your application. And in this case, we're doing a poker simulator using a Monte Carlo method to come up with odds for not just for hole cards, because you can get that anywhere, but also the odds for different hands post flop. Like, what's your chance of winning if you flop a set, if you flop a high set, if you flop a low set, things like that. So, uh, in any case, when you write an app, you start by putting it in the class app code, and the system looks for that. And the app code has a top that's associated with it. And if you remember, the tops are like threads. And if you start a new thread, it has its own copy of app code. So that way you can do multiple things. And in this case, it's a poker simulation program. And so the objects that it has a list of players, it has a deck of cards, it has a class called Hand Evaluator that will analyze the hands and determine uh, what the hand is. Is it a full house? Is it a straight, a flush? Whatever it is, the Hand Evaluator figures it out. And then it has another class called Stats, where when it runs millions of hands, it will keep track of how many wins and losses there were, and then that will give you an estimate of the probability, and a very good estimate uh, if you run a large number of hands. So we're going to see that we're going to run millions of hands. We'll each simulation of a million hands in order to determine the probability of the of winning with any given pair of hole cards. And this is something you can find on the internet anyway. But then it'll also take specific hole cards and specific flops and tell you what the probability of those winning are after playing hundreds of thousands of rounds. In any case, this is the code, and the constructor for app code takes a top, and in this case it creates a new deck, and the deck has to be past the top too, because the random number generator is stored in the top, because the random number generator in C# is not thread safe. So you have to have a random number generator for each thread. And so I put it in the top. And that's why the deck needs access to the top, so that it can use the random number to shuffle the deck. And what happens is every function that you put in app code will become a command for the system. So here's display copyright. So if I run the program and we're going to see that it's going to start right up with okay, so I must have left it yeah, I need to kill it over here in the task manager. So if you run the program, see there's a function here called display copyright with no arguments. So if I run the system, and we can see that it's already doing some of the simulation, but if I come over here and type display copyright, I hope I spelled it right, then you can see a box comes up. I should have probably made it a bigger font, so I'll make that a little bigger and size the window for you. So that just illustrates how the interface works. Every function that you put in the class app code becomes a command over here when you type it into the command line. So let's just I don't know if it probably uses the same window again. Okay, well, it printed the copyright information again, so each time you type display copyright, it gives you another copy of the copyright. Not a big deal. Probably something I should fix. In any case, let me close this now, and you can see here's the code that does the display copyright, and here's some of the variables that I'm using in this class. So I've got 2 hole cards and 3 flop cards, and you get to set the number of players. So obviously the probability, say you've got a pair of aces, the probability of winning against one person is much higher than if you're playing with 8 people. So this will demonstrate the different probabilities for the different numbers of people. There's a function here called deal the cards, and that's the code there for doing that. Let me make a little more room here. This is a function for displaying or getting a string of every player's hands. This is a function that scores all the hands. So and it calls evaluate all hands. It's kind of interesting. I'll follow through a little bit on this. So it will evaluate all the hands. So it gives you starts with a top score of 0, and then for each player it determines the score of their hand, and that's done with that hand evaluator object. And if we take a look at it, it says score hand. So let's go look at that. So score hand. Now you know that you get 7 cards in Texas Hold'em. You have 2 hole cards and 5 community cards, and so you have a total of 7 cards that you can use. And it's got to look at all possible combinations of 5 cards in order to evaluate which 5 cards is the best for you, then gives you your score based on that. And And here's the function for get score of hand of 5. So let's go take a look at that. And I don't want to get into too much detail, but essentially it evaluates, first of all, it sets a Boolean if you have a flush, a straight, or a wheel straight, which is a little different because it has an ace in it, but it's the lowest possible straight because the ace being used as a 1. Then if you have a straight and a flush, then you have a straight flush, and then it will it'll give you a score that'll be higher than everything else because that's the best possible hand. Although it will base it after the hand is sorted, it'll use the high card as the value. And if it turns out it has a wheel flush, then it's going to use the second sorted card because it's the 5 that's going to be the highest card in the straight flush if it's ace 2 3 4 5. The next highest hand is 4 of a kind, and there's 4 of a kind with a smaller kicker, and there's 4 of a kind with a bigger kicker. So those are scored differently. So it's possible that 2 players would both have 4 of a kind. If there's 3 cards on the board and they each match it with one of their whole cards, then it's going to come down to whoever has the bigger kicker. And then it checks for full house, it checks for flushes, straights, and the wheel has to be handled differently because of the way because even though it has an ace in it, it's still the lowest possible straight. 3 of a kind, 2 pair, 1 pair, and no pair. They'll all get a score such that whoever has the highest hand will have the highest score. Okay, so that's an object called the hand evaluator. It just performs that service of evaluating hands. Going back to the app code, and I don't want to get too much into the code for the for this, but it's not too complicated. It's not a big deal. I still need to clean it up. I've commented out stuff that I probably need to erase at this point. In any case, let's take a look at the interface, because what happens when the system starts up, it runs a batch file, and the name of the batch file is _system startup, and that's this file here. And so any commands that are either part of the system or have been added in the app code class can be executed in this batch file. And it also shows the interface here. Like I said, for code that I'm going to use myself, I like an interface where the functionality is associated with the function keys. So here we've said that function key 1 just brings up the help. Function key 2 will edit all the batch files that you have in the system, including this one. And function key 3 will edit something called auto start, and function key 4 will edit the system startup file. That's this file right here. And function key 6 will make the whole card stats and run each simulation 10,000 times and put it in the preflop.txt. Now this particular program, you don't really need any interface, but I had this in there to test things. And it'll also make all your after flop stats and run each one 10,000 times. And it puts this data in a file called preflop.txt and puts this data in a file called postflop.txt. And then it goes on. It creates two windows. One is called messages, and that's where the system will put error codes. And the other one's called info, and it also defines where your data directory is. And in this case, it's relative to where the execution takes place in a folder called Syscom PokerSim 23 data. This verify closing off means that when you shut the program down, it doesn't ask you, are you sure you want to shut it down? Go to command line will put the cursor on the command line so it's ready to take a command, and then it says show display info false, and that's like a debugging thing that when I'm debugging it, I would set that to true and I'd get a lot of information in the info window. And then the last thing this batch file does is it starts another batch file called auto start. And remember, the system startup batch file is really for the developer to set up, where he can set up the interface and what windows are and where they're located and all that stuff. And the auto start is more for the end user to set up. And here we can see that when auto start runs, this is why you don't have to, it doesn't really require any interface. It runs two commands: make whole card stats, running it 1 million times, and it puts the result in preflop 1million.txt, and then it calls this other command, make all after flop stats, and it runs each simulation 100,000 times and posts it in this file, postflop 100,000 A. I don't know why I got the A there. I think I was experimenting with something. Now the important thing here is, see the little 1 in square brackets with a colon? That means that the first command will be run on thread 1 and the second command will run on thread 2. They both take a long time to run because the simulation has to run many times to get an accurate result out of the Monte Carlo method. And so that's what happens when the system starts. We already saw it once. Let's do it again. And here we can see the two windows that are running. Let me set them up side by side. So I go ahead and put this over here. So on the left, it's doing the simulation of the post flop the post-flop statistics, and on the right it's doing the pre-flop statistics. So the pre-flop runs 1 million times to get its values, and the post-flop only runs 100,000 times. And you can't really tell, but they are both running right now. And what we're seeing here, let me make the font a little bigger. So in these text windows, you have these two little buttons at the top, so you can adjust the font and make it bigger or smaller, make it just a little smaller. So the first thing it's doing is saying, well, what happens if after the flop you have two undercards? So you have a whole card of 5 of clubs and 2 of hearts. That's, if you know how to play poker, that's not a good hand. Oh, by the way, the this one's already done. It runs a lot faster. Oh, it's not completely done. Oh, it is done. I'm doing it for 3 players because I'm playing poker on Zynga, and they have tournaments with 3 players. So this only shows the statistics for 3 players, but normally I would run it with everything from 2 players up to 10 players, and so it would take a lot longer. Now, over here, what it's saying is that if you have 2 undercards, so if your whole cards is the 5 of clubs and the 2 of hearts, and the flop is king of spades, 9 of hearts, and 7 of diamonds, with 2 players, you're going to win a little more than 20% of the time. And then it goes down from there. If you have 3 players, you're only going to win about 8% of the time. With 4 players, 4% of the time. All the way up to 10 players, you're only going to win less than 1% of the time. So if you have 2 undercards after the flop, you probably should just fold. Over here, let me make this a little bigger. And what it's showing you is the top. You've probably seen charts like this on the internet, but it shows that with 3 players, and this top chart is for unsuited hole cards. So if you have an ace and a king, you have a 74% chance of winning against 2 other players. And if you have a, let's see, unsuited, no, that's a pair of aces. So a pair of aces, and everybody knows that, aces get beat. It's the best possible hand, but they do get beat. So against 3 other players, you still only have a 74% chance of winning. Pair of kings is 69%. Suited ace king is 49%. So if you're playing 2 other players, you got about a 50-50 chance of winning with an ace king. Anyway, back over here to it's, the pre-flop stats are not as interesting. I think people have seen these before, but what's more interesting is this simulation over here. So it's taking a look here. So what happens if you have 1 overcard? What happens in that case? In this case, the whole cards is king of clubs, 4 of hearts, and the flop is 2-9 queen. So you got 1 overcard, 1 card that's bigger than the rest of the flop. Well, with 2 players, you're only going to win 42% of the time, and with 10 players, you're going to win just a little over 4% of the time. So it's still not that great a hand. Now, if you have two overcards, it's still not that great after flop. Remember, you've got no pairs. There's really no potentials, straights or flushes. And so against one other player, you're going to win 47, a little over 47% of the time. By the way, I've run these statistics with 1,000,000 hands. That's what I have over here. And of course, it runs 10 times slower when you have a 1,000,000 hands. And it gives pretty much the same statistics. So here, now, this is interesting. This shows that it's a little higher than it was for the 100,000, but there's a difference here. Is there's still a potential that you would get runner runner to a straight, and that's enough to give you a slightly higher percentage. So anyway, here's what happens with two overcards. So if you have two overcards, oh, I think we looked at this already. You're still going to lose most of the time. So anyway, that's how the program works, and I think I'll pause this here, or I'll let it run in the background, because and I'll go back to essentially showing you the code. So this make all after flop stats, if we go look at the function, because this is a function that was implemented in the app code class, and oh no, this is another batch file. So this shows all the different types of hands that it will do the simulation for. So 2 undercards, 1 overcard, 2 overcards. We saw those already. Then there's bottom pair, middle pair, and top pair. Then there's an overpair where you have a pair in the hole that's higher than anything that came up on the flop. Flopping 2 pair. And then there's a lot of subtle differences between things like an open-ended straight draw using 2 hole cards. That's a stronger hand than an open-ended straight draw using 1 hole card, because it means there's 3 other cards out there that could tie you. There's the inside straight draw using 2 hole cards, an inside straight draw using 1 hole card. There's the sucker end straight draw. That's when, in this case, you've got a 4 in the hole and the flop comes 5, 6, 7. And the reason this is referred to as the sucker end of the straight draw is somebody could have an 8, and then they're likely to get a higher straight than you. There's the flush draw. There's a nut flush draw. That's where you have an ace. Hang on. Yes. In this case, you've got the ace of clubs and a 2 of clubs, and there's 2 more clubs on the flop. So from this program, from this simulation, you can see what your chances of winning with that are against any number of different players. Let's see. There's having low trips using 2 hole cards. So in this case, you got a pair of 3s and you flopped a set. So the other thing is you could have low trips using 1 hole card. So this time you got a 3 and an 8, and the flop came up with a pair of 3s. That's not as strong as having 2 3s in the hole, because it means there's another 3 out there. And if somebody's got it, then they could pair up another card of the community cards and make a full house, or they might just have a higher kicker than you have. And then there's all these other different things. So top trips using 2 hole cards. So this case you got 2 kings and you flopped a king, so you flopped a set of kings. And this is top trips using 1 hole card. In this case you had a king and you flopped a pair of kings. And again, that's not as strong because somebody else might have that other king. Then it comes down to who's got the better kicker. And then the last 4 things that we look at is what happens if you flop a low flush. So in this case you got 2 3 of clubs and 3 more clubs come up. Or what happens if you flop a queen flush? What happens if you flop a king flush? Or what happens if you flop an ace flush? And of course in this case the ace and the king and the queen are in your hole cards. So that would be you had flopped the nut flush, which is a great hand. A little cleanup here at the end, but that's a batch file. Now here's something that I want to tell you about the batch files, where it says %T, so it's running whatever top the batch file was run under. That's the top that the different commands will run under, and %T gets expanded by the command processor to be whatever the current top is. Also, %1 over here, you can see %1. That will be the first parameter to the batch file, and in this case it's the number of rounds per simulation. And then %2 is the file name where the results will be stored. And if we look down at the bottom, there's a command called twin save to file, followed by the name of the text window, which is in this case after flop stats, and the %2, which is the name of the file where it's going to be saved. And remember, this was called from auto start over here, so the name of the file is going to be postflop 100,000.txt. Now so this batch file is mostly just a long list of calls to do after flop stats, and the argument is the window where the results will be displayed, and also the label for, in this case, 2 undercards, and also the next these next parameters are the first 2 are the hole cards that you're trying to get the statistics on, and the next 3 are the flop cards. And so what it'll do, and this last parameter is passed in as the first parameter, and we know in this case it's 100,000. So what it's going to do is it's going to run 100,000 times. It's going to shuffle the deck, but it's going to make sure that player 0 has the hole cards 5 of clubs, and 2 of hearts, and that the flop is the king of spades, the 9 of hearts, and the 7 of diamonds. And then it gives the statistics for how often player 0 will win in that situation out of 100,000 times. So what we saw was that against one other player wins a little over 20% of the time. So it's a crummy hand. I think we can understand that. So now I'm going to pause the video. I think the simulation is still running. So I will pause the video. Now here before I pause this, we're looking at an overpair. And this means that the whole cards is jack and jack, so it's got an overpair. And the flop came out 2, 8, 10. So you've got a pair in the hole that's bigger than any of the flop cards. Against 2 players, you'll win about 82% of the time. But against 10 players, you'll only win 20% of the time. Well, 19% of the time. Now, this next one that's coming up is 2 pair. So you've got a jack and a 4, and the flop came jack 4, 10. And against 2 players, you're going to win 86% of the time. And against 3 players, you win 75% of the time. And then as the number of players goes up, the probability goes down. Now, it's when you're using these tables, you know, I realize that before the flop, a lot of people might have folded. And even after the flop, people might fold. But you should still, if you're playing with 6 other players, you should use that stats, because the players with the best hands will not fold and the players with the worst hands will fold. So you should still use the stats for 6 players, which means that with 6 players, you've got a 53% chance of winning. I probably should add the expected value. So let's say out of the 6 players, like 3 players besides yourself stay in. Well, you've got a 53% chance of winning, but you will quadruple your money. So it's probably a good idea that if you flop 2 pair, you probably want to stay in. Doesn't mean you're guaranteed to win. We can see that you're going to win just a little over 53% of the time against 6 players. But if you do win, and say 3 other players stay in to the end, then you'll make 4 times the money. So the expected value is essentially to about double your money. So probably want to stay in and probably want to get a little more money in. Now, if somebody's betting back against you hard, who knows? They may have flopped a set. And so that's, you can't just play by the odds, although the odds are useful for figuring things out. Now this is interesting. So open-ended straight draw using 2 hole cards. Well, it means that you're on a draw. You don't have a good hand yet, because you need to complete the straight. And in fact, with two players, you're going to win 58% of the time. And then it's going to go down where here we're seeing that with six players, you're only going to win 31% of the time. It's still a good hand to play because if you make the straight on the turn of the river, then you've probably got a very strong hand and you'll be able to put a lot of money in, hopefully, and hopefully somebody will call you. And if you don't, well, then you're going to let it go. And we can see here that if there's a total of 9 players, you're going to win about 30% of the time. But with 9 players, say 6 stay into the end, or let's say 5 stay into the end, and so you've quintupled your bet. Your return is 5 times what you had to put in. So a 30% chance of winning gives it a good expected value. So even though you're only going to win 30% of the time, in the long run, you probably want to play these cards. Okay, so I'm going to pause it now. Okay, we're back, and I paused the video, and this thing is now finished. So we've got all those different scenarios. So here we go, flush draw. Actually, to be more exact, it's flush draw with 1 overcard. And so 2 players, you're going to win 56% of the time. 10 players, you're still going to win over a quarter. We're going to win 28% of the time, so not too bad. The nut flush draw, let's compare the two. So 10% higher chance, so 67% compared to 56%, and that holds up. You have a 36% chance of winning as opposed to a 28% chance of winning. So drawing to a nut flush is definitely a good thing. Let's look at some of the really good hands. I didn't put in here if you flop a house or if you flop quads. I think it's pretty obvious if you flop a house or flop quads, probably going to win. The here's if you flop low trips, even against 10 players, you got a 75% chance of winning. And against 2 players, well, not against 2 players, with 2 players, that's 1 opponent, you've got a 97% chance of winning. Nice odds. However, if you have low trips with 1 hole card, those probabilities drop a fair amount. So you can see that instead of 96, it's 93% against 1 player, but against 10 players, only a 57% chance of winning. Middle trips with 2 hole cards, even better. Middle trips with 1 hole card, still better. Top trips using 2 hole cards, Very solid hand. 98.3% of against one other player, and even 86% chance of winning against with 10 players. Now, if you flop a flush, that's very good. But if it's a low flush, here you've got 2-3 of clubs, and the flop came up with 3 clubs. It's an 87% chance against one other player, but 46% chance against 9 other players. So, not that great. Queen flush, big difference. 94% against one player, 64% against 9 other players. King flush, significantly better. So 96, 74, so 10% better to have a king flush than a queen flush. And of course, if you flop an ace flush, you're going to do good. Even against 9 other players, you're still going to win 81% of the time. Okay, guys, so that's pretty much it. If you send me a message on Facebook, I'll send me a message on Facebook with your email address, and I'll text you these odds tables. I should point out that I could have probably made this more efficient. So I've got 6 cores and 12 threads. It's kind of an older machine, but it runs good. And I did this whole simulation on one of those threads. And this simulation in the other thread, so you can see in the auto exec or the auto start.txt that this is done on thread 1 and this is done on thread 2. So I could have divided this up on a lot of different threads. Then I would have had to save the results in separate files, or just kept them as in RAM, and then put them all together at the end and kept track of when different threads ended and stuff like that. But since it only runs once, like once you run it, you've got this file, so you don't really need to run this a bunch of times. So I didn't bother going through all the stuff of putting it on multiple threads. But it wouldn't be that hard. See, in this batch file, make all threads, I could have just put each of these where it says do after flop stats. I could have put each of these on a different thread. I could have added another parameter for what file it goes to, and then at the end I could have had another process that waited for all the threads to finish, and then take all the different files and combine them into one big file. But since I don't have to run this more than once, well, actually, I've run it a lot of times in the process of writing it and debugging it. But now that it's done and it's working, wow, I was running that whole thing in debug mode. I wonder how much faster it would have been in release mode. Don't know. It's kind of CPU bound, so it's likely to have been significantly faster. And I'll experiment with that. Anyway, guys, that's it. Have a great day. Remember, love everybody, be happy, and drive carefully. Bye bye.